Good evening and welcome everyone to tonight's webinar. We will be discussing inequalities in linear programming with ClassPad.net. My name is Amy Chow and I will be moderating tonight. Our presenter tonight is Dr. Karen Greenhouse. Before we give our introductions, I just wanted to let everyone know that we will be keeping everyone muted and have all the videos turned off just for the sake of the webinar quality. If you have a question, you can type it in the chat panel and I will either respond back in the chat or ask Karen to stop and answer the question in front, to the entire group. So now would be a good time if you don't have your chat panel open to open it up before we get started so that you can have that ready to go. So as I said, my name is Amy Chow. Karen, if you'll move to, thank you. And I have been in math education for the last 14 years. I am currently the training and product manager at Casio Education. You can see some of my primary responsibilities, but tonight I will be assisting Dr. Karen Greenhouse.
Hello, and I am Karen, and you can read for yourself, but I've been a teacher forever, it seems, 30 plus years. And I still teach at Drexel University, and I work with teachers in all around the country, New Jersey, Louisiana, to my most recent things. So what I'm going to be doing today is sharing some ideas about teaching inequalities and sharing some activities with you. I'm actually trying to encourage you to play along with me a little bit. So I'm going to switch my screen right now, if I can remember how to do that. Sorry. There we go. Can everyone see that? ClassPad.net. We're going to be exploring ClassPad.net, free web-based math software. You can start exploring. So what I kind of want you guys to play along. I'm going to be sharing several activities, and I want you to try and do some of the stuff with me. I'm going to start off showing you how to do stuff, and then share an activity, and hopefully we can kind of interact that way. So the chat panel will come in handy here, because then you can type your things in. You can be practicing. If you're struggling with something, you can ask me a question, that type of thing. I have lots of activities that we're going to look at. We probably won't get to all of them, and I am going to share a document with you that has all the activities in it by the end of the webinar, and also that will be attached in a follow-up thank you email. So you'll get all these activities. Don't feel you have to copy down the links or anything. You'll get access to them. So I'm going to pop into ClassPad.net. So this is the website, free. If you're never been exposed to it before, I would suggest watching this kind of cool little video that does a really fast blurb on what it's about. But there's webinars. We have a lot of prior webinars that you can go look at, basics of what it is. We have free activities that you can look at. We have video tutorials. So this landing page is full of a lot of interesting things that will give you a little bit more insight. I'm going to log in. I'm already logged into my account. If you don't have an account, I really suggest that you create one, because then you can save all the activities that I have, that I will be sending to you. And you can also make your own. So I'm going to pop in, and oh, it's kind of scary. So that's not where I wanted to pop. This is all the papers that I've been working on. And you can see I have folders by courses, and there's a webinar on how to do that. So if you're interested in how to set up and organize your papers, there is a webinar already on that. But I'm going to start a new paper just to get started. So we're talking about inequalities, and I wanted to start with sort of how do you use ClassPad.net, which is this tool to actually have students show their work. Because one of the things when we first start with, solving equations, and then we move into solving inequalities, we want them to solve and find solutions. Usually we want them to do it by hand, like just show us their work, So I'm going to just show you how you can actually use ClassPad's text ability. So this is ClassPad. I click anywhere and I get the choices of something to do. I want to use a text box, and I'm going to basically move it over here where I need it. And let's say this is something that we give a student. So I can give a direction, use the text box to give directions, and then I'm going to set up a problem. And so here's my problem. And what I want you to notice is in the text box, you have the ability to change the size of your font. I tend to work with 3, but we'll stay in 4 right now. And you can also do math type. And when I click that, I want you to notice what happens. I get this little math line, I guess is what we want to call it. And then the template for all the math tools comes up. So I can put in exponents, I can put in fractions, I can put in logarithms. If I go to some of the other tools, I can put in signs. So you can use the text to actually do real mathematics and show the numbers the way they should be shown. So let's say I ask the students to solve an inequality, like they've just come off understanding how to solve equations. So now I give them, I kind of throw it up, and I'm going to make a fraction. So I'm using my keyboard, but I could also use the template here. But I'm going to hit 1 and then kind of backslash, and that makes a fraction. So there's my fraction 1/2 x plus 3, and I want it to be greater than, let's just pick a number here, 12. So let's say this is what I tell the students to do. Solve this for x. And so they've just come off linear equations, so they kind of know that I'm supposed to be using inverse numbers, inverse operations. How could you use ClassPad.net to show your work, which is what we want students to do. And even though this is a technology platform, you can show your work, and it's by using this math type line. So what might a student do when they're looking at this? Well, they know I have addition of 3, I need to add its inverse to make a 0 pair. And so I could go back up to this line and add in, and I know some of you who are, whoops, I'm adding in a -3. And those of you who are math teachers are going, what are you doing? Why is she doing horizontal instead of vertically, which is how we tend to teach students to solve equations? Well, this is my new pet peeve, not pet peeve, this is my thing that I do with my Drexel students, is we really should be focusing on properties. And you are adding the additive inverse. You're using addition properties to make, if you look at it, this is really a 0 pair. These two will 0 out. That's what we're actually doing when we usually tell students to subtract 3, but what they really should be doing is adding a -3 using their addition properties. So over here, what do I end up with? So now my next line, I'm going to put the end result of this. I still have the 1/2, and I'll use the template this time just to show you. And I still have my x because I haven't done anything with it yet. But this is now 0, so I don't need to write that in because of the additive identity property. Adding 0 to anything gives me back this. So I don't need to put that in, but that's my 0. I still have my greater than, and 12 plus a -3 is a +9. So I have shown the step that I did up here in my math type. So this is really nice thing about ClassPad.net. You can actually have students show their work even though you're in a technology tool, but it's better than, say, a Word document where you can't do the fractions and such like that. So now what's my next step? My next step is to make a 1 here by multiplying. And I'm going to multiply by 1/2. Actually, you know what? I'm going to make a new line just to show you what I'm doing. So I'm going to just show this one problem. So what is the reciprocal or multiplicative inverse of 1/2? It's 2/1. And I would multiply. So I am relying on the idea of inverse properties, inverse numbers, and using my multiplication and addition properties instead of some of the, quote, tricks that we teach students. And I still have my greater than sign. And on this side, I'm going to do 9, and I'm going to make it into its fraction form, right? And then I'm going to do the same thing on both sides. I'm going to multiply by the 2/1. And let's use the template this time. And so now what happens here? Well, because I multiplied multiplicative inverses, this makes a 1. So I am left with, oops, I don't know why it went up there. There we go. I'm left with x on this side because this is 1, and the multiplicative identity says 1 times any number is itself. And then greater than, and 9/1 times 2/1 is 18/1. So here's the answer students get. And if they're just first starting to work with inequalities, they're like, well, the answer is 18. But they have to understand, what does this actually mean that the answer is x is greater than 18? Well, it's any number that is greater than 18. Well, that might not make sense to students. So this is where you then might add in the graph, the visualization of what this answer means and how it's different than x equals 18, that one possible number. So here's where you can pull up a graph. So again, I'm going to click somewhere on the screen. And here's my graph symbol. That will open a graph window for me. And I'm going to get a equation sticky out here. And I'm going to enter my answer. So my answer was x is greater than 18. And I don't see it because of my window. Sorry, let me zoom in. There we go. So watch what happens. So this is the answer. So the answer is different than it would be if it were an equation. And so now you can tell the students, well, this represents the answer. And all the shaded regions are possible answers that you could have. And what does this line right here represent? Well, where is it? And it is the line where x is greater than 18. So it's a line at 18. If we actually look at the axes here, there's an open circle here. And if I click on it, that is the point, 18, 0. But why is it open? Well, greater than means that's not actually a solution to the problem. It means I have to pick numbers greater. I could have 18.1, anything in this blue shaded region. And so the dotted line, you can start talking about, what's the dotted line mean? Well, the dotted line means that all the points on this line are not solutions. It's just sort of the boundary line. And here's where ClassPad.net has the ability. So I have this equation, but maybe I want to look at other possible answers. You can, down here at the bottom, there's other things you can do. So we've graphed an equation. I could add a table. I could put a picture in here. That doesn't make any sense right now. I could also plot some points. So this is what I'm going to do. I'm going to pull this one up. So this is just literally plotting points. So I'm going to just plot a point, a random point. Actually, let's make it be something that's on the screen. 20 and 5. There we go. And let's change the color so it stands out a little bit. So anytime you're in a sticky, all of these things are called stickies. This is a text sticky. This is an equation sticky. This is a graph sticky. This is a plot point sticky. Anytime you're in a sticky, there are 3 dots, and those are always indicating that there's some settings you could change. So I could change the labels of the points to not be X and Y. Right now that makes sense, so we'll leave it there. But here's this point that I plotted. And as I move it, notice it also moves in the table. And this point is now in my shaded region. Well, what does that mean? Well, students can test it out. They can say, okay, 2510, if it's in the shaded region, that means it's a solution to my problem. And it means if I plug in the X value here, I will get a true situation. So we could actually do that and pull up a calculate sticky. So there's a lot of ways right in one little space where students can start exploring what is an inequality and what does it mean and what does it mean to have a solution to an inequality. So our original problem was 1/2, I'm trying to remember, somebody remind me, 1/2 X, right?
Yes.
1/2 X. And so instead of X, I'm seeing if this is a solution, right? I'm verifying this is a solution. So the X value here, instead of X, I'm going to use 25. So times 25, whoops, is supposed, +3, was it?
Yes, +3.
And it's supposed to be greater than 12. So let's calculate. And if it's a solution, then the answer is yes. And the solution, it's in fraction form, so that's a neat thing, but let's click on, it's 15.5. Is that a number of value greater than 12? Yes, so that solution does work. So that's what you're testing with students. You're trying to help them understand what it means to be an inequality and how come the solutions, there's infinitely many solutions because it's this entire shaded region. I did want to, one thing you can point out to students, let's change this to equals and just look at the difference. If I change it back to equals, which they would have been used to doing before they got on here, why is it not doing anything? Now what happens? The entire shaded region is gone, and X is just this value. This is the only solution that's going to make that true. But if I put back the equality, inequality, I now have lots of solutions. So I know, actually, this is what I meant to show you. Sorry about that. I meant to show you when it's an equal sign, if you look in the equation sticky, you'll see there's a table, and it will give you the table of possible solutions. So X is always 18 in this case. It's the only way that makes it work. But the minute you make it be an inequality, the table goes away because there are infinite possible solutions, and therefore that's very hard to put into a table. Because I could move all around this shaded region, and this shaded region goes on forever, and all of these that are in the shaded region are possible solutions. So that's just one way to start with students. I did want to scroll down here a little bit more. I'm going to pull up another graph. If you have not played with ClassPad.net, you have infinite space. You can scroll forever, add as much as you want. You can move things around to arrange them, put in directions, put in places for kids to write answers. So and you'll see that in a little bit when we're looking at some of the problems. I did want to kind of go through some things about just graphing inequalities in general. So I'm going to pull up a graph again, and I want to show you a couple things that you can do. So let's just make up, let's use less than or equal to. So less than or equal to, a couple ways you can get it in there. In the template, if you go to, here's your less than and your greater than symbols. But if you want the ones with the equal sign as well, you have to go into the math. So let's say I want less than or equal to 5. Down, that's linear. So you'll notice it's not a dotted line anymore because the equal sign is included. I can plot more than one inequality on here. So let's do an exponential one. Let's do y is greater than, my hope, this is bad when you do these on the fly because sometimes they don't intersect, but yay, that one did. Actually, it's a really boring one. Let's do a little subtraction here. Move it down a little bit. And I'm going to change this one. You'll see why. I want them to intersect because I want you to see what happens when they intersect. So let's make this. There we go. So notice each one has its own shaded area. They match. And students should be looking for when they see a dotted line, because that's part of what they learn too about inequalities. Sometimes they're given the graph first, and then they have to write the equation from the graph. So if they see the dotted line, they should automatically know that equal is not part of the inequality. But if there is a solid line, equal is part of it. And when I click on the graphs themselves, the key points come up. So it's open circles when you don't have that equal sign. So these are values, but they are not solutions because they're open circles, right? And then in the solid line, you'll see the difference. Why isn't it doing my intersection? There we go. So you'll see the difference that this one right here, this -1, 0, is a solution to this inequality up here because it's a solid point. Up here, this one, however, is not a solution to the green one because it is an open one, okay? Now, one of the things, we're going to get into systems of equations in just a minute. Let's say we had to solve this, and solving a system is find the intersections, right? So you'll notice that each one gets its own shaded region, and where they intersect or cross, it's sort of a different color. It's a little hard to tell on this because they're, let's see if I change the color. Red and blue make purple, right?
Yes.
I'm trying to make it be an apparent color change. I don't know. So let's make this one blue and see if we get purple. So we sort of get purple. So you could just leave it this way and say, oh, okay, so the solutions that work for both inequalities are the region that is the intersection, the where they cross, right? So this red, any point, and let's get our points out again. This is really important for students. And let's make the points a different color altogether. Let's just do a couple points. And this is a nice thing because now I can just move these points. And so I might tell a student, can you put one of the points where it's a solution to the blue graph, but not a solution to the red graph? And so they would, you know, hopefully realize that they'd have to put it here. And then this point is just a solution to the red, but not a solution to the blue. And so where would you have to put a point where it's a solution to both of those inequalities? And it would have to be in the purple area, right there. So that's something you want to be doing with inequalities. And so it's really nice to bring the points in so that they can move things around and really explore, and then use your calculator to plug things in, those types of things. What I wanted to show you, though, is when you do have intersecting inequality graphs and you want to just see the region, and this is going to come into play when we're looking at linear programming problems. When you want to see just the region that is a solution to both, you can go up to the settings of the graph again. So remember, anytime you're in a sticky, if you look for the 3 dots, that's the setting. And you'll notice down here, inequality plot. So obviously this is only a setting that applies when you have an inequality. It defaults to a union. So you're seeing solutions to both plus their intersection. But if I click this, I can change it to where I'm only going to see the intersection, the solutions that work for both of them. So now I can see very visually that, that this purple region is the only place where answers, solutions, points would satisfy both equations. So that's a really nice feature to turn on and off, and it really comes into play when we get into linear programming. So I wanted to just kind of go through that real briefly, and then we're going to start looking at some activities. And so I am going to share these with you. But before I do that, is there any questions? Does somebody want to see something, try something, anything like that?
No, I think we're good.
Okay, I'm going to be putting a link in. You don't have to play along, but it is a lot more fun to play along. I put in a link. This is to an activity. So there's one. How many activities? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 activities. We're not going. Don't panic. We're not going to go through all of them. But I am going to go through just a couple. I want to make sure we get to linear programming, which I think is a really applicable thing. So this first activity is really an exploration of just inequalities in general. And you'll see it's several different activities in one, and you'll see kind of like what I was just doing, but it's already set up. It has an equation, it has points already on the screen, it has the equation on the screen, and then it just has some directions for the students to explore. So they're really kind of, in this first one in particular, just exploring what does it mean to be an inequality versus an equation. So you'll see this is nice. If it's already set up for students, they can't really mess anything up. They're just kind of interacting. But it says move the points and put them on the line and explain what those points on the line represent. Like why, if they're on the line, what does that mean? So students are kind of hopefully applying things they already know. And then it's asking them to go through changing it to different inequality signs. So first, let's go look at less than. And what happens when we do that? It's very slow here. Now it's shaded. And so then they're asked, okay, so do those points still satisfy, and what does this mean? So they explore and they move things around and they compare. What does it mean if this point over here is not in the shaded region and this one is in the shaded region? What's the difference? So this whole first activity is getting them to understand just what inequalities are, but it's already done for them. They don't have to do the graphs. All they're doing is changing the symbol. So it's a nice way to help get them started. But as we scroll down the activity, notice, this is something, if you haven't created activities, this is something, I create these a lot. I'd like to recommend is that you have your questions and you kind of leave your questions by themselves and provide another text area, and usually in a different color, so that students have a place to actually answer the question, so that they're not doing it in where you ask the question, but they're able to kind of write their own observations here. And then when they're done, you know that to look here for their answers. And they kind of get in the habit of realizing that anytime I always use yellow, and don't ask me why, but I always use yellow. It helps them know I should always answer my questions in the yellow space. Like, so if this were a homework that I had sent out to a student, I know to look here for their solutions, and they know how to write them in there as well. And this would be where they show their work or the calculator. So I want to show you that this activity goes into lots of different types of inequality. So it's sort of the same, but now instead of a linear inequality, we now have a quadratic inequality in a shaded region. So they're going to go through the same process. Put the points where they're on a solution. What does it mean? Put them in the shaded area. What does that mean? They're going to be talking about that. And then as they scroll down, we're getting into, cubic. So lots of different examples of inequalities, so that they are really trying to understand it doesn't have to always be a line. I know that we tend to start with inequalities that are always linear, but inequalities can be other types of graphs. So you want to introduce that, and it's really to help them get that understanding of what an inequality is and where are the solutions that satisfy an inequality, which is very different than the solutions that just satisfy an equation. And the last one, this is one that I think is more like an application. Here's how many different inequalities? 3 different inequalities. So notice the shading, and it's basically do you understand what that means to be a solution? Find a point that's a solution to just the red one, or a solution to the green and the purple one. So these are things that they hopefully now, after having some exploration up here, can apply. And you could then go in and also hide the union and do the intersection, except it's only going to do the intersection of all of them, which is a very small piece right here, so that they could see it. So just different ways to help students understand what inequalities are. So once they get that understanding, then you can move into systems of inequalities. So the next 3 activities, I'll just share one with you. I really want to get into linear programming, so I'm going to just show you one of the systems activities that I have. So systems are where you have, let's just do it. So all of these are activities. They're adapted. Some of them are adapted from illustrative math activities, which are free online resources that I've just turned into an actual problem. So one of the things that students have the hardest time with, and I'm going to ask you guys to see if you can do it yourself, is they're given, word problems, systems of inequalities, and they're asked to write the inequalities out from the word. So I'm going to give you a second to read this. We've got fishing boats, and there's some constraints. So an inequality is when you are given constraints. It can't be bigger than this. It has to be more than that. It has to be less than this together. Those are constraints on the numbers in the problem. So the hardest thing for many students is trying to figure out, is that greater than? Is that less than? What are my constraints? Those types of things. So I'm going to give you just a couple minutes to read this. And then we're going to see if we can come up with the constraints. All right, so anyone who's brave and wants to try to give me one inequality that comes from the situation. We have boats that hold at most 8 people. We have adults and children that could be on the boat. They can only carry 1,200 pounds of people and gear. There's some weights given to the people, 200 pounds for the gear, 10 pounds per person. We're going to assume an adult weighs 150 and a child weighs 75. All right, so we've got something from Tom, and actually I'm going to go right into the equation. So Tom is saying one constraint is X plus Y. So X, I'm going to assume, we'll say X is going to represent our adults and Y is going to represent our children. So it has to be less than or equal to 8. So that's coming from this sentence right here. Each boat can hold at most 8 people. So you can't go over 8 people. So the adults and the children has to be less than or equal to 8. Anyone else? And so I'm going to just take that right now and plug that here. Oops, that was not what I meant to do. I don't know what just happened there. Come on. All right, when all else fails, trash it and start over. X plus Y. And one thing I want you to notice is you can enter them. It doesn't always have to be Y equals. You can enter it exactly as you wrote the constraint, and it should still work. So now here we have this graph of that. So now we know our solutions are in this shaded region, at least right now. Any other constraints? All right, I'll give you another one. The boat can carry 1,200 pounds only, so it has to be less than 1,200 pounds. And we need 200 pounds of gear plus 10 pounds of gear, and we know how much the people weigh, right? So there we go. Thank you, Amy. So we're going to get another equation in here, and this is the one that has to do with weight. So we have one equation that has to do with the number of people, and now, depending on the number of people, we know that an adult's 150, we think. Is it 160?
Well, I went ahead and added. It was
Oh,
150 per
Amy
person.
is getting ahead of us. Amy added the 10 extra pounds per person, so it's 160.
Yes.
Look at her reading the
For
problem.
adults.
And then the children were what? 75 plus
5,
10.
so
Okay.
plus 10, the 85.
There we go. And it has to be.
And then I went ahead and subtracted the extra 200 pounds of gear from the 1,200. So it has to be less than.
So Amy's getting really
less
fancy
than,
on it.
I think it should be, I guess, less than or equal to 1,000.
Because now I'm looking at Tom's. Tom got 150x plus 75y plus 200 plus the 10 pounds for x. And he's really made it. Amy's done a combination.
Yes.
I'm just going to do, here's what I'm going to do.
Plus the 200.
Okay.
Okay.
Has to be
less than or equal
less
to.
than or equal to, yeah. All right, so this is now what we call a system of equations, right? And so when students are a system of inequalities, when students are solving, oops, and it's both red. Let's make that a different color. When students are solving equations, they're looking for the point of intersection. But when they're solving inequalities, there's more than one possible combination, right? So they're looking for the place where there are answers that satisfy both. So if you look at the colors, so we have red and, is that blue? Let's make that blue. We're looking for the point where they intersect. So blue is this one. So if I pick a point in here, it's only satisfying the blue equation. And if I pick a point here, it's only satisfying the red. So I'm looking for the answers in this. So I'm going to turn off union and just look at the intersection, because that's actually what I'm interested in. But here's something that I wanted to show you. We really want students to think about the context. And what is the context? We're talking about people, right? People and weight. So are there any constraints that are not necessarily in the problem themselves, but where some of these answers don't make any sense? So for example, let me get a point out. Remember, this point tool is a very nice little handy dandy thing. Let's just make a point. Whoops. I don't know why I did that. I'm not sure what happened there. I changed my constraints a bit. Huh. So here's this point, right? So this could be a possible solution, but if I put the point here, and let's look at what it means. Adults are the X, and Y as the children, this is saying I have -1 adults and 5 children. Does that make sense? Could that be a possible solution in the context of this story? And I'm looking at Tom's answer. Yeah, so this is where you really want students to also think about, well, you know, you can't have negative people. That doesn't make any sense. So I can't have a negative adult. That doesn't make sense. And so really, I need to make sure that the adults are always greater than 0, and the children are always greater than 0. So you can add constraints to your inequalities or your equations to limit what's actually colored in, because we don't actually care about the solution area in the negatives because it doesn't make sense in the context of this problem. So to do that, you can use I know it's here on the screen somewhere. This little symbol right here, I don't know what it's called. I call it the straight up bar. I'm sure that's not what it's called, but
I think that's what we all call it.
Okay, we all call it the straight up bar. So it is also on your keyboard of your computer. It's usually like right underneath or above the backward slash, like under the back. But when you put that in, you can actually constrain your values that show up for it. So I only want to see the X values that are greater than or equal to 0. And I'm going to put that bar in again. I only want to see the Y values that are also greater than or equal to 0. And what that's going to do is hide those constraints for me. And I probably want to do it here too, but it seemed to have taken care of it as well. So that is something to think about too. You can also use inequalities to help you constrain and set limits on what you actually see in the graph. And actually, I do want to do it to the blue one because I don't need to see this piece of the line, right? So I would do the same thing. Straight up bar, X greater than or equal to 0. And I really like Classpad because it's one of the only ones that lets you actually constrain both the X and the Y at the same time. Most only let you constrain the
walk all over you and you don't make them respect you. They're not known.
Is somebody talking?
Yeah, I think someone actually accidentally unmuted themselves.
Unmuted. Oh well. All right, so that's just systems. So there are I'll just look at them real quick. There are 2 more systems of equations that you can look at. I like this one. I've taken a lot from illustrative math because it's free, so it's kind of nice to convert them into activities. This one's sort of an application. They've learned how to, you know, constrain a region and look for values that work in it. So this activity, like, it gives them a picture, and now they have to come up with, it gives them the 2 equations right here, but then they have to decide what kind of inequalities do I write from these to just see region A in my graph or to just see region B in my graph. So that's a kind of a fun activity for them to work through. Like, how do they use inequalities to make just these specific regions show up and only those specific regions? So kind of a neat activity. So 3 activities on systems of equations. I did want to get into linear programming, and linear programming is linear inequalities, but where you're actually trying to solve a problem. And I love these, and I don't know why we don't do them more in algebra, because we're working with linear equations and inequalities so much. We should be using linear programming because it's so realistic. It's making decisions. What's my best cost value that I can do? So you'll see in the paper that I'll send you, and I'm trying to think which one I want to do the most. I'm going to do this one right here. There's 4 linear programming activities. We'll probably only really look at one of them. So this is the snack problem. Let me send this to you if you want to kind of play along. And so linear programming is just working with inequalities, sometimes equations, but and constraints, and looking at that intersection, which they call the feasible region, and coming up with some decisions. So in this particular problem, we have snacks and peanuts and potato chips, and it's in a daycare, I think, and they want to make sure that they're giving them the right amount of fat, and so there's a lot of constraints on it right there. And they have to figure out what the constraints are first of all, and then how many peanuts and how many potato chips can they give the students in order, or the children, in order for it to meet the requirements that it has. What are my possible solutions? And so they're going to come up with the constraints again. So let's just take a minute here. We've got, let's use X for peanuts, Y for potato chips. So again, the hardest part for most students is coming up with these inequalities and thinking about the constraints on this. So each serving of peanuts has 15% of the daily amount of saturated fat, and potato chips have 10%. Each one has 12% fiber, and potato chips contain 5% fiber. And you have to consume no more than 60% of the recommended fat, seems like a lot, and you want to have at least 30% of the recommended fiber, and you have to have at least one serving of peanuts and potato chips every day. So just kind of think, see if you can come up with some things that are constraints for this problem. And it's different from a system of equation, which tends to be 2 or 3. This one might have many, many constraints depending on the situation. I'm going to give you one. X, which we're going to use as the peanuts. If I have to have at least one serving of X, that means my peanuts has to be greater than or equal to 1. So that's a constraint. And the same thing with my Y, which is my potato chips. If I have to have at least one serving, then I need to have my potato chips greater than or equal to 1 as well. So I've already kind of narrowed my window to right here, this little feasible region there. Anyone else want to throw something out? We've got fat and fiber. And we can change the percent to its decimal equivalence. I think that might be the best option. I know, I'm making you guys do math this late at night. Sorry. I'm going to have to do it for you, it looks like. All right, so if I'm looking at, I want no more than 60%. So that means less than or equal to of fat. And I have 15 for the peanuts and 10. So I would do 0.15, so I'm going to change to decimal form, plus the potato chips has to be less than or equal to
0.6.
0.6. So here's my constraint. So watch what has happened. I have on, if you haven't figured it out yet, I turned off for this activity the union, because I only wanted students focusing on the intersection, the feasible region. So notice that it's only showing me the intersection of my inequalities or constraints that I'm coming up with. And I think there's one more. Peanuts is 12% and 5%, and we have to get at least.
So 0.12
plus, what was it, 0.05? And at least would be, and this is hard for everyone.
Greater than or
equal to. I could use this down here. You can also use your keyboard to get greater than and equal to or less than and equal to. You hit the, I guess it's the greater symbol and then the equal sign, and it kind of, well, it puts them together. So that's another way to get that symbol in there. And what did I say it was, 30?
Yes.
So this right here then is where all possible solutions are. And in linear programming, like all of these would be a great solution, but in linear programming, you're looking for the optimal solutions. And those, once you learn this, are the vertices of this region. So how do you get those points? If I click on the graph, and I click on this one, oh, it's not gonna let me do it. I'm looking for the intersection points. And so you know that they're a solution to those intersections because it's got the different lines showing. So this is one of the feasible regions, and they're in its standard form right now for this particular problem since we're dealing with servings. I'm going to change it to decimal so that we see the decimal version. So again, settings, change it to decimal. Standard form is and so there we have some better answers. So now I can click and get all the key intersections here and find out which one is maybe the cost one. Come on. They're all supposed to stay. I don't know why it keeps going off. Come on. There we go. Did I lose? I lost one. I don't know why I keep losing one. All right, it doesn't seem to want me to have more than 3 at a time. So what they're going to do is, you know, what answers make sense? Let's say we have money, which one's going to cost us the least? So I think down here at the bottom, if they cost 12.4, which one of these numbers is going to give you the least expensive? So what they would then do, all right, there they all are, is take these numbers and plug them in and find out the least expensive if that's what they're going for, or maybe the most expensive. So this now is what we call linear programming, because they are then going to use these key points right here to help make decisions about, you know, it's usually about a cost, which one's the least expensive or the most expensive, what decision would you make? This is linear programming. So it's really linear inequalities, several of them, and you're looking for the intersection of all of them and the vertices of that intersection region is how we do linear programming. So, and then here's where you get your calculator out, right? If we know that cost equals, where was it? 12.4x, and if I have x up here, let's say I pick this point, 1, plus, whoops, plus, what'd they say peanuts were? Potato chips for 23, oh, they're more expensive, okay. And then 4.5, how much is that gonna cost me? That's a lot. And then I do the next one, so then they pick the point that gives them, if they're going for cost, the least or whatever it might be. So this is how you do a linear program problem. And I have 3 other ones in there, so there's 4 total that you could look at. And you know, one has to do with, this one has to do with cars, so something that, you know, is definitely realistic. This one over here has to do with manufacturing. The cost of manufacturing and the number of hours. So it might be which one's going to take the least amount of time for the least money. When am I going to make the most money? Those types of things are what they're looking for, is what points of the feasible region are going to satisfy the constraints that they need. And then the last one is on bike production. So things that students, I think, could relate to coming from. So I'm gonna actually, let me just throw the PDF in that has every activity in it in case you're interested. Oh wait, I have to do it a different way. File.
So while Karen's doing that, are there any questions on some of the stuff that she talked about today? I think everyone was able to follow along pretty well.
I love inequalities because they're just fun to do. And you can use inequalities to shade things in too. Like if you want to make a circle, you just do an inequality type of thing. So did the link go through for everyone? I just put in a document that has all of the activities. And it also has some link. It has a link to the ClassPad.net page where you could sign up for an account if you don't have one. And then it also has a link to our YouTube. And the YouTube channel is where we have lots of how-tos. And in fact, I think many of these programs, I actually did a mini math lesson on them, so they walk through the programs a little more in depth. And we also post the webinars there as well, the ClassPad webinars. So you could see the past ones that we've done, because we have done a couple on just the basics of ClassPad.net if you haven't explored that. So those are there as well. So if there was no questions, I am finished, and I really appreciate all your attention and playing along with me. I know that's hard to do, especially on a Thursday night doing some math. And one of the things we're starting, for anyone who might need it, if you attend a live webinar and you need a certificate of attendance that just shows that you did an hour of PD somewhere, they're not CEUs, they're just a certificate that says you attended a webinar for an hour. But if you need that, just let us know when we follow up with the email tomorrow to thank you. Yes, Tom, I would agree with you. ClassPad does make it easy. Well, I don't have any other questions. Amy, do you have any? Let me get that.
No, if you'll just pull up that last slide. Again, just to let everyone know, as Karen mentioned, a lot of this information is on that attachment that she sent over, and it will also be in the follow-up email that we send out. But for those of you that are watching this at home on during a different time, or if you guys end up sharing with your colleagues this video once we get it uploaded, these are some of our social media sites. We post all of our information on the upcoming webinars on Facebook, Twitter, and Instagram. And like Karen mentioned, that YouTube site is where you can find previous webinars as well as additional videos that have been created attached to like mini lessons that Karen does.
And just how-tos.
Yeah, and
like
lots of
I know there's one that's just how to do an inequality. So if I went too fast, you could go watch that.
Yeah.
I know I go fast. All right. Well, thank you so much for joining us. We really appreciate you spending Thursday night with us.
Yes.
See you guys again.
Thank you all very much. Have a good evening.
Good night.